In this video, we're going to solve higher order homogeneous linear equations with constant coefficients. As you can see, our first example is the third order differential equation. It has constant coefficients, it's homogeneous, and it's linear, right? To solve this equation, first we need to obtain its corresponding characteristic equation. In this case, it's going to be third degree polynomial equation. So it's going to be m to the third power, which matches the derivative, third derivative, plus 5. I'm using exactly the same coefficient. M to the second power, right, for the second derivative, equals 0. And now we'll have to solve this polynomial equation. There are different ways to solve polynomial equations. In some cases, if you get lucky, you can use factoring. And it looks like that's the case, right? We can simply factor out m squared from the left-hand side, and we'll get m plus 5 times m plus 5 equals 0, right? Once we factor, we need to set each factor equals 0. M squared equals 0, m plus 5 equals 0. Let me remind you, before we move on, let me remind you that when we're solving a polynomial equation, its degree, in this case degree 3, tells us how many roots we're going to obtain, how many solutions to that equation we're going to obtain. So if we have degree 3 here, it means that we're expecting to obtain 3 solutions. Now, as I look at what I got at this point, so in this case, I'll just square root both sides and I get m equals 0. And for this case, m equals -5. So I only got 2. Where's the third one? Well, here I have to pay attention to that second power. That second power means that the solution m equals 0, it actually a repeated solution, it happens twice. The way to think about it is to maybe write m squared as m times m equals 0, right? I can split up this way, and then after setting each m equals 0, I'll see how there are actually, 2 of them. So we say its multiplicity, m equals 0 is solution, but its multiplicity is 2. So multiplicity 2, so it happens twice. And m equals -5, so we found 3 of them. Now, what do we do with them? Once we find solutions to this characteristic equation, it will help us to obtain linearly independent solutions of our differential equation. So each solution of the characteristic equation produces one linearly independent solution of the differential equation. So let's see how they're going to look like. So for the first case, we have repeated roots, right? We have m equals 0, m equals 0. These are repeated roots. I'm going to bring in the table that we saw in the introduction video, and it will help us to figure out how to put together linearly independent solutions for differential equation. So according to this table, when we have real root that has certain multiplicity different from 1, so when it repeats, we obtain linearly independent solutions of this form. So if it's multiplicity 2, the first linearly independent solution will be e to the power that root times x. So let me start writing. So we'll say linearly independent solutions right here. So from this first root, I'm going to get a linearly independent solution e to the power 0 times x. But when we have repeated roots, the next one will be x times e to the same power. So the second linearly independent solution will be x times e to the power 0x. Now, if we had, let's say, one more repeated solution, another 0, then we would continue and say x squared times e to the power 0x, and so on and so forth, depending on the multiplicity. So here we only have multiplicity 2, so that's how far we're going to go. And now, how about the next, or the last solution to our characteristic equation, m equals -5? Well, it's just distinct. It means that it's not repeated. Real root, right? -5 is a real number, and that's kind of like the simplest case. In this case, linearly independent solution to the differential equation has this form: e to the power that solution times x. And we do that for each distinct solution. Well, we only have one, right? So we're only going to have one linearly independent solution of this form. So from here, linearly independent solution is going to look like this: e to the power -5x. And once you obtain also, as you can see, the number of linearly independent solutions is going to be corresponding to the order of the equation, right? Because of all that, and now we can obtain general solution. So general solution is just basically taking all those linearly independent solutions and putting them together into a linear expression. And the only thing that I can simplify a couple things here: e to the power 0x, it's same as e to the power 0, which is same as just 1, right? And here, same story, so it means I'm going to get just x. And now that I cannot simplify. So, answer, which is general solution. So general solution is going to have this form: y equals, and then we take arbitrary constant c1 and multiply it by the first linearly independent solution. It's just 1, so c1 times 1 is c1, plus c2 times second linearly independent solution, so that's x, plus c3 times the third linearly independent solution, e to the power -5x. By the way, there is no specific order to them, so you can call any one of them number 1 or number 2. I'm just following my order here, but yeah, you can use any order. But yeah, that's how a general solution is going to look like. So once again, real quick, the process is: step 1 is to obtain characteristic equation. It's going to be nth degree polynomial equation. Solve that. If you can factor, that's the easiest method. Sometimes you can't. We'll see that in the next example. You solve, you obtain all solutions to that nth degree polynomial equation. Keep in mind that you'll have to end up with the same number of solutions as the degree, which is the highest power. And then from each solution that you found, you're going to obtain specific form of the linearly independent solution of the differential equation. If you find that table helpful, please use it. And then from there, once you have linearly independent solutions, you're going to use them to form a general solution right here. So that's the answer.